As I watch people walking in, I have this like sinking feeling in my stomach. It's like so many people to disappoint. Uh, I wish there was a pill that I could take right after this talk and forget all about it. That'd be awesome. And I would like a similar pill after gym, that you take before gym, and then you forget you went to the gym, but you still feel good after the gym, right? Because I go to the gym, but I don't like going to the gym, right? So this is Dr. Andrei Alexandrescu Esquire speaking. By the way, do you know what Esquire means? What is it? What is it? So yeah, it means loser. It means they append to every name, like, yeah, you're a loser, but we give you a title because we can. That's what it means in European English. In American English, it means you're an attorney. And I have a PhD, so I say doctor. And by the way, I got Esquire in a mail from Lufthansa, which was, remember that flight we canceled on you? You're not getting your money back. Esquire. So ever since, I thought, you know what I'm going to do? I'm going to put doctor and Esquire in my name for all airlines. Because there's no legal binding. You could put Reverend there. Reverend John Doe, you're good. Well, what? A cardinal, yes. Fantastic. There's no legal obligation. You can put anything. So I put that, and they think, oh, he's a doctor and a lawyer. So, whoa, we better not take this money from this guy. Give him a champagne. All right, so today we're going to talk about the application of large language models and generally AI to systems programming. So there's been a lot of progress lately in machine learning of the statistical kind. And of course, there are huge requirements for data to train these models. They're very computationally intensive. So these are significant problems to overcome. But we are at this interesting point in computing history where huge quantities of data do become available. And we do have more powerful interconnected computers. So in the future, I predict that computers are going to read and understand things that, like web pages intended for humans to read. That was my prediction from 2007 in China. And actually, the funny thing is, I made this prediction, and I kind of mentioned, by the way, automated translation, there's not going to be a need for human translators. And I got some dirty looks from the translators in the back, in the cabins there, because there were a lot of Chinese people in the room that did not speak English, so they had translators and headphones and everything. And the translators had to translate, my job is done. So not a pleasant thing for them. I got some dirty looks, but what you're going to do, you can't stop progress, can you? All that good stuff and more has come to fruition since. We do have enough data to train these large models. We do have enough computational power to train those models. And today, we can't afford to not talk about it. We can't afford not to talk about it. I've been speaking to too many systems programmers who think that ChatGPT is a joke. I don't think we can afford that anymore. So we're going to talk a bit about large language models and what they can and what they can't. Then we're going to talk a bit about how to use ChatGPT for systems programming. And then I'm going to, maybe let's pop a level up and discuss a bit things like creativity, taste, and skill, all of which are important in producing good code or good art for that matter, or good craftsmanship and that kind of stuff. And I'm going to end by engaging in a few predictions. And I gave a similar talk a month ago or so. And I actually did not change the predictions because a couple of them actually did come to fruition already. So things are moving fast, right? Then we're going to summarize. Now, there's a lot of hand-wringing and questions and debates between experts, and there's a lot of discussion at the moment about how is AI smart? In what way is it smart? This is smart in the first place because a lot of people say it doesn't do even as good as well as a parakeet. And then there's people who say, oh, actually, it has like self-awareness, and be careful with that kind of stuff because it's gonna eat your lunch or whatever. And in between all of these, all of these opinions, there's the truth. And the truth is very difficult to envision at the moment and to talk about because we have very limited understanding of these systems and how they work. But there are a few things that we can say with certainty. For example, we can answer the question, how good can you be if all you do is text? So all you train on, say you're a human, you grow up with no practical experience, you just read books. And how good can you get by training on text? And a lot of people say AI is not good because it only has text for training, and therefore, how good is text for a world understanding, for developing an understanding of the world? Actually, I would contend that human language is human complete. Human language is human complete. It's a complex and expressive embodiment of everything that we are. Everything that you can. I mean, how many people in this room have killed a man? Okay, there's no hand. Okay, so good baseline. Okay, good. I'm happy. Me neither. But, a lot of us can imagine from, we've read Dostoevsky or a variety of police books and whatever, and detective novels, Agatha Christie, what have you. We've read a number of books, and we have a good understanding of the immense feeling of guilt and shame and pain we'd feel if we ever engaged in that, in that behavior, right? So we have an understanding of it, even though it's purely academic. The same goes about many human feelings that maybe we have not experienced directly, but we can, by reading about them, we can engage, we can empathize, we can sympathize, and we can understand and get an understanding of these feelings. So, people say, I have no words too often, because you do have words. I mean, you do have words all the time for expressing how, what's going on, right? You do have words. There would be very few cases in which, yes, I do have no words, but those are very rare. And I bet money that none of those have. Oh, okay. At the end of this talk, you're going to say, I have no words for how awesome it was. Yes, that's going to be appropriate. Okay, golf chuckles from the audience. Thank you. So if you understand language, you understand what it means to be a human. Ways of doing things, our motivations, our aspirations, the best things we can do, the worst things we can do. And, assuming that language models, large language models cannot gain some sense from text, it would be very reductive. It would be not the whole story, right? So training on text is actually quite powerful because human language is what humans are. Now, I'm sure you know that these language models are trained by, let me predict the next word, and that's the way the training is done. You don't need you don't need training data, simply just give the sentence and please predict the next word, and so on. And they get really good at predicting the next word. And one question I get from many of my fellow engineers would be, how come we get from that simple task, which is predicting the next word, all the way to complex reasoning and understanding and that kind of stuff. But, consider this. At the end of an Agatha Christie novel, therefore the murderer is. You literally need the context of the entire book to predict the next word. It's not as easy as predicting the next word given a context of 5-6 words. Right? It's predicting the next word given a very rich context, which is everything you know as a human, right? Plus everything you know about that particular book, for example, plus the context of that very sentence. So it's multi-scale. It's all of this like long-term knowledge and medium-term term understanding you get from the book, plus the short-term understanding you get from the sentence. So predicting the next word is actually quite a lot. And doing it well means reasoning. There's no doubt about it. I mean, there's plenty of evidence about it. And, people can actually they can argue about what exactly reasoning is or whatever, but there's a lot of interesting insights you can get by training on predicting the next word. I hope you agree. I mean, even in math, therefore x and y are equal or not equal or whatever they are at the end of a theorem. If you say equal or not equal is the difference between getting it right versus getting it wrong. And it's simple as that, right? But you do need to understand the entire theorem enunciation, the entire theorem statement to be able to make a salient prediction of the next word in the demonstration, in the proof. Now, one important thing that we need to internalize very well about these large language models is that they don't issue only the top one prediction. They compute a whole probability distribution, which means, in view of the fact the real murderer is at the end of the novel, the model is going to predict a lot of people with different probabilities. And what it does is it's going to give you the most probable one, which we're going to discuss in detail. That's not always the best, right? And but it kind of has a good understanding about other possibilities as well. I'm not sure if you've played with the temperature thing in ChatGPT. Did you? Temperature? Yeah, a few. So temperature is like you set up like the randomness in the output. It's like sometimes it chooses like the less likely thing. Why? Because creativity is less likely. And it gives more, quirky answers. It gives you, the murderer is Agatha Christie herself. I don't know. It gives you some crazy answer. And in the same goes in these models that produce like drawings and paintings, pseudo paintings, as it were, right? With AI, you can set up the temperature, you generate more cubist painting, or more crazy painting, or more Picasso-like painting, right? But it's very important to understand that these models are not limited to predicting like the best, the most likely guess, but they have the gamut of predicting a bunch of possibilities. That actually means they themselves and we can look at the less probable outcomes to make more interesting decisions. Now, once the model masters the probability distributions, run it backwards. So this is new. I should make a historical note as follows. So let me open a parenthesis here. I actually did work in machine learning. They called it machine learning because AI was it was the winter of AI, whatever, up until the 90s. And people said, oh, AI is bad because Lisp. I mean, this is Lisp. Lisp was the AI thing, right? And then statistical learning came about in the 90s when computer became pretty good. And then they called it machine learning to avoid the bad reputation. And then with the large language models, oh, wait a second, it's not machine learning, it's AI again. They kind of forgot, I don't know, so they recycled the term. So I could say it worked in AI, but actually it was called machine learning applied to NLP, natural language processing. And actually predicting the next word in a sentence was considered a solved problem. I remember to this day, there's a model by IBM which predicted the next word from a context of the previous 6 words with accuracy better than humans. It was a solved problem. So you predict like they had human experts sitting down and reading sentences like idiots, right? So, oh man, can't believe I'm doing this, but I'm getting paid. And then they run the model, the automated solution. The automated solution was a bit better than the humans by only using 6 words of context. Now, okay, so if it was a solved problem, how come it's because running in generative mode is new? So this is new to this current crop of large language models. Instead of predicting the next word, you actually emit the next word, right? So literally you're running backwards. It's literally, you just plug in the wrong way, right? You plug in so that it generates text instead of reading and predicting text. So then it's going to predict sentences that are actually likely to be uttered by human beings. You see what I mean? Am I expressing myself? I should use ChatGPT to generate this stuff, right? By the way, new rule at the conference, don't go to talks that ChatGPT could do for you, right? And don't give talks that ChatGPT could do for you, right? That's a new rule of conferences. Actually, conferences could change because a lot of the conferences could be like, you know what? This tutorial, I'm not going to go to it because ChatGPT is going to be tirelessly teaching me things, right? I ask anything, it just answers and, it just goes. So once the model masters the distributions, you can run it backwards, it's going to generate text for you, new things. That's why you always need a context. You always need, like when you interact first with any of these language models, you need to give it at least one sentence. Why? Because it uses that as a seed to generate the next sentence that is likely to be uttered by a human being. Right? That's the way it works. That's everything about the way it works, right? Okay, that's a bit much, but that's a lot about the way everything works. Great. That being said, there's a different thing that baffles many of us engineers about the way these things work, and that is this thing. It can generate similar but not identical responses. And that's because of a different artifact that is present in these language models. By the way, so let me get the temperature a bit, okay? Who already knows about the continuous representation? Continuous representation of vector. Okay, a few, very few. Excellent. I didn't want all room to raise their hand, and then I will have to skip the next 30 slides, and I'm done, right? So I'm in a way, I'm glad that we have a lot of information to exchange here, because there's one extra tidbit that just a few of us kind of have studied, which is very important to how these things work. Continuous representation. Excuse me. So continuous representation is the linchpin of this whole thing. So there's two things. One is you run it in generative mode, so you run it backwards than predicting. So that's number one, very important. And number two is continuous representation. Since the 90s, Joshua Bengio, a researcher, has developed a neural network model that actually learns for each word a vector, an actual vector of floats. I'm not kidding. This literally, it was an array of floats, like in C, right? Each word would have 64 of these floats. That was the first model. I'm not sure how many, but on the order of 64, on the order of a few dozens, right? Of floating point numbers. And it was learned. And before that was unheard of. Before that, the way it worked, it was, well, you take the vocabulary of the English or Norwegian or what have you language, you sort them by frequency, and you ascribe an integral number to each of them. A is 0, N is 1, and so on. And you get all the way to Zazzle, or whatever it is, right? To the word with only Z's. And that's your number, 8 million, or whatever the size of the vocabulary is, right? And then you work with these numbers throughout your language model. All of your tools are going to use those numbers, right? And it turns out that in the modern language, in the modern tools, there is also a step like that, because it's easier to work with integers than strings. But the problem with this representation was that, okay, cat is number 442, and dog is number 238. What does the distance between these two numbers tell you about cats and dogs? Does it tell you they're mammals? Does it tell you they're kind of both quadrupeds or whatnot? No, it doesn't tell you absolutely anything. The Hammond distance between two numbers like that is just completely random, right? So Hamming distance. That means the integrals carry absolutely no information about the words. And working with them, it's purely symbolic in nature and gives you no extra information. Now, with Joshua Bengio's research, he said, you know what, that's not good. We should convert those integers into a vector of floats. And that changed everything, because the way those floats, those 64 floating point numbers were learned, it was such in a way that similar words clustered together. And that changed everything, like absolutely everything. It means all of a sudden you have the 64 floats vector representing a cat and the 64 floating point vector representing a dog are close to each other, but both are far away from pink. Oh, they could be pink. I don't know. Umbrella. I don't know. Air conditioner. Whatever, right? They're far away from semantically far away words, and they're grouped together in semantically meaningful ways. And that has two very important consequences. Number one, it's a lot better to work with because then you have, oh, wait a second, so it's close to that guy, so you can create clusters, you can cluster things, these are nouns, these are animals, these are mammals, so all of a sudden you have a much more meaningful categorization of things. And number two, when you use it the other way in a generative manner, you're going to generate things that literally did not exist before. Literally did not exist before. And this is driving us completely nuts. Because it says things that have never been said. It does say things it does say things to which similar things have been said, but it doesn't say exactly it does say things that are completely new. But, it's just that they're similar to other things because when it generates when it runs backward and it generates these sentences, it can replace cat with dog. So if you trained on a thing that, the dog is catching the mouse, it can replace with the cat is catching the mouse because cat is semantically similar to dog, and then it knows that. And it can generate a sentence that's meaningful even though it didn't see the actual sentence the cat is catching the mouse. That's a bad example because definitely there are sentences like that. But it can generate any number of sentences that are similar but not identical to those already seen. And this drives us completely nuts because movies, books, everything about AI so far, everything about AI in the 20th century has been rule-based. Rule-based. Meaning, oh, I know these AI systems. They have the if and else and if and else and if and else, and they compare all these cases and they kind of go to the logical but not rational conclusion, right? Movies are full of that kind of stuff, right? It's like, oh, this robot, it says stupid things and kind of makes the wrong decision that is kind of technically correct, but in reality it's completely insensitive or kind of meaningless or whatever, right? Because we're used to the 80s, which were rule-based. Like all the 80s were like, oh, I'm going to build an expert system. Remember the expert system? Who's old enough to know about expert systems? Thank you very much. A lot of us, thank you. That dates us. Yeah, and, more than my hair, it dates us. But this is the reality. In the 80s, it was all about expert systems. How did expert systems work? Lisp. If, then else. Oh, if that, this, then that. And there was an expert who would talk to the software implementers and would say, oh, no, you don't take that, you take the else now, right? That kind of stuff. There's nothing statistical in it, right? And of course, there are like all the movies and with computers going into a loop because, in the 80s, people knew about loops. That infinite loop and it would explode, the head would whatever, and the lasers would, I don't know. So a lot of things, right? And we got conditioned like that as the public to think about the new systems the same way. Like, oh yeah, so it has all these rules and it creates new sentences like, that's stupid, crap GPT, right? And actually you're surprised when you use it a bit and you're like, wait a second, it can't go like that. It can't come from an expert system. Actually, to reduce, kind of to just gloss over quite a few details, I could claim that the answers ChatGPT gives to you have no if. There's no code with if and else in it. It's a bunch of matrix multiplications. Why matrix multiplications? Because that's how neural networks are implemented. It's just you multiply a vector with a matrix, and then you activate, and again another one, and you do that 19 times and whatever, and many times, and you're done. Right? There's no if, there's no decision tree. Of course, there's if and else, like, is the answer too long? I don't know. That kind of stuff. Or is the question too long because it does have a limit. It says, oh, you ask a too long question, you got to pay us more money, right? That kind of stuff. But there's no decision tree in the decisions that ChatGPT makes for your or large language model. It's all statistics and matrix multiplication, that kind of stuff, right? So it turns out that that's the way it works. Therefore, and for that very reason, there's any number of examples on the internet about things like, oh, write me a poem in iambic pentameter about the awesomeness of NDC Kongsberg. It's going to do it for you. It's just going to do it for you. They should put it on the website. It's going to do it for you. Prove this in that style. Do this in that style, right? do something in a way that is coming from combining things the way floating point numbers are easy to combine and average and process in any way is the very strength of ChatGPT, right? So remember this important thing. Continuous representation, it actually goes beyond that, because I gotta make this quick detour. It turns out that continuous representation is not only for words, because it turns out that words can have multiple meanings, right? So the word bank can mean like a bank that you sit on, it could mean a bag you rob, it could mean a variety of things, right? And therefore, it can have a single vector. So there's actually vectors associated with phrases, and there's more complex representations for groups of words and that kind of stuff. And to make it better, the way these language models work, they work at fragments of words, because maybe you misspell some words, and it's got to understand from the syllables what you mean to say. Maybe you spell bank as bonk. It's still going to understand, which is entirely remarkable, right? So many times the misspellings are fine. I mean, the last thing I would want, and the first thing I would hate, would be a ChatGPT that is a grammar Nazi. I mean, come on, it's like, oh, you misspelled that thing. Did you mean, or are you idiot, right? So yeah, that's not a good idea, right? And I have to say that this is creativity. Generating new things that are in the combination of different styles is part of the creative work that we humans do. I mean, think of this, much art and science comes from things, and and a lot of engineering comes from combining things, old things in new ways. Think of how many inventions come from first principles. Very few. How many inventions come from combining a variety of things that had already been invented? Most, right? Think of the air conditioner. Think of the copy machine. Think of the camera. Think of like anything is a combination of things that had been invented, right? In a new context. Oh, wait a second. I could do it like that, right? Now. As it goes to code generation, the story changes a bit, not a lot, but a bit. And I could say that these large language models are the absolutely most expensive way to learn C++. Because they learn like everything about all languages, right? They know multiple languages and that stuff, right? And they know multiple programming languages. And there's no place in any of these LLMs that says this is the grammar of C++. Not even like these are the keywords. There's no knowledge of the keywords. ChatGPT has no idea that if or while or switch or co-wait are keywords. Has no idea. It just learned statistically that they are likely to appear in different spots. Did you ever get ChatGPT to generate unbalanced parentheses for you? 1, 2. Yeah, you can, but it's very hard. Right? Agreed? Agreed? Yeah, so it's very difficult. Essentially because ChatGPT does not know you should pair parentheses at all. It has absolutely no idea. As I said, the most expensive way to learn C++. You read like a bazillion about C++, and then you're like, maybe I should put a closing parenthesis right here. Right? Which is ridiculous in a way, but it works. It does code in a way that is not the way our current tooling does, and is not the way humans do. It's a bit in between, right? So the way I discovered you can convince ChatGPT to generate unbalanced parentheses is to really press it to do things in a specific way. And once you press it a lot, it's going to try this, it's going to try that, and I think it's going to start digging into the lower probabilities outputs. And it's going to say, this idiot doesn't like anything I say, so let me try this. So it's going to try unbalanced parentheses on you. So actually, ChatGPT is very good at finding typical bugs, because there's actually a corpus of bugs on GitHub, and it can detect really gnarly bugs, such you're off by 1, and you're changing a container while iterating, and you're having the limits wrong, and that kind of stuff. And it's very good at that kind of stuff. Uninitialized variables are easy, and again, uninitialized variables, it doesn't detect them in a lint-like way, because lint-like is rules-based. It goes to the code, and it looks at, essentially, it deterministically, figure out that you're using something that has not been uninitialized. ChatGPT does it by just looking at it. Just like, you may have an uninitialized problem here, right? Which is amazing, and crazy, and stupid, and remarkable, and all of these things are all at once, right? Now, the nice thing about code generation is ChatGPT can, I'm going to use them interchangeably. Okay, new parenthesis. ChatGPT is the golden standard of code generation. There's no tool that's better today. Period. I tried them all. Google Bard, not as good. Meta's Code Llama, not as good. They just try, they're good, they're also ran. The gold standard is ChatGPT. Okay, so I will use in this talk LLMs and ChatGPT interchangeably just because ChatGPT is the best we have right at the moment, but that's unlikely to last. So hold on to your breeches. You never know what changes, right? Things can change real fast. But I tried like Bart, as of yesterday, it was still not as good. So even the new Bart that they claim it's better, but it's not. So anyway, so parenthesis closed. Now, ChatGPT can create infinite new solutions by combining old patterns from coding. So it can actually create custom solutions for you, generate code for you that has literally not been written yet, right? And it can apply solutions that are typical from one problem domain to another problem domain, which, as we discussed, is a measure of creativity. And that's very nice. So let's talk about a bit about two distinction I would like to make between application programming and systems level programming, which is very subjective. I mean, don't hold me to it. It's for exposition mostly. I will distinguish as follows. We have high-level application programming, where the interesting part is the idea, and the realization can be a hack, and it's totally fine. You can like hack it out in JavaScript real quick, Python, what have you, everything. It's just like you put it together and it works. You have an e-commerce site, you have whatever, an application on your phone, whatever it is, you just hack it out and it works and you're happy and you make money. Great. There are many paths to getting where you want to get code-wise. There's one great idea, the implementation is cost. Is your liability, it's what keeps you from getting the idea to money in your pocket, right? To the realization of the idea, right? So that would be high-level application programming, I would say. And the usage patterns of these applications is predictable. People generate this. People write this code to fit most of the public they're aimed at, and that kind of stuff. So that closes the idea of, well, we have this application program domain, subdomain, if you wish. And then we have the low-level systems programming, which is quite different, I would argue. Quite different, friends. I mean, come on. How many ways can a binary search and still be good? Right? You can't hack it out really poorly. It's got to be like there. Like you got to pay. You pay for every semicolon you put in there, right? Every comma you put, every word, every statement, whatever, you're going to pay for it. It's going to end up here, right? On your forehead in the form of like age. So it's the right and narrow, the straight and narrow is much more straight and much more narrower than in application programming. I mean, if you just look for, replace substring in Python, you're going to find a bazillion examples, right? If you want to replace substring in C++, there's going to be much more fewer ways because you're looking for the most efficient way that's going to work most efficiently for all cases. So it's quite different. And here, your code is not cost, it's value. Question, how many here in this room work for technology companies, high-tech companies per se? High-tech, okay? Thank you, hands down, so about half. How many of you work for companies that are not high-tech, but they are programmers nevertheless in companies that are not focused on high-tech per se? Okay, I see like a lot of you don't have the courage to raise. It's not bad or anything, right? But I do have a lot of friends who work at things like hedge funds and in finance and in medical applications and whatnot, right? So things that are not high-tech in purpose, right? And they are on the expense side of the balance sheet of the company. right? They're the cost. They're, the hedge fund guys are like, oh, my manager kind of hates me because I'm costing them money, right? But in high tech, actually, your code that you produce is the asset of the company, is the value. They keep it like, for dear, unless it's open source, in which case everybody keeps it or whatever. You see where I'm going with this, right? So here we have code that is an asset, its value is the good thing, is the product. In application programming, code is like, damn, I have to write this code. Like everybody talks about, I want to write this application, I don't want to write any code. Right? Like, oh, no code, we have no code solution. Oracle, no code solutions for you. Like this is kind of a point of pride for companies that offer that kind of stuff because they promise you to write no code as if that's a good thing. I mean, come on, for us, it's like, oh, wait a second, code was fun. Supposed to be. Right, I'm seeing, is it? Okay, so I gotta stay in this range here. So the right path is narrow. There's little code that works perfectly well, and there's many constraints. Usually systems code is performance constrained, size constrained, all of the above constrained. Many uses possible. You can't predict exactly which. Think of the STL implementations, for example. They do their absolute best to squeeze the last bit of performance out of everything, right? So we're going to focus today on the low-level systems programming part, because it turns out that high-level application programming is a lot easier to do for these large language models. It's like, yeah, write me in JavaScript a function that does this and that. It's going to do it for you. It doesn't matter that it's inefficient or it has issues or what. You just, you're going to hack it out, right? It turns out that for systems code, it's not as easy at all. And I'll give you an example. I gave ChatGPT a code interview. And it was interesting. It started very well. It started like shining colors, and it was awesome, and it did great. And it did generate, for the most part, it generated working solutions. However, I asked it to implement str, which is a classic interview question, like a warm-up. It's not a difficult thing to do, but there's something peculiar about str. Number one, there's only one good way of implementing it. There's no two ways of implementing. There's only one. Literally, if you change one comma in the code that follows, you're going to get it wrong. There's only one implementation that's good. Number two, that implementation is not on the web. I assume this is a stunned silence right now going on, right? Not an awkward moment. Okay. So the way I mean is str is a function that is so old and so widely used that everybody and their cat is implementing it in assembler. It's implementing it using vector instructions, it's implementing using a variety of optimizations, and it's an assembler function. The only available implementations in C, or C++ for that matter, are tutorial level, which are not efficient. And therefore, ChatGPT is in the situation. I don't have any good examples. I have the tutorial examples. And he's asking me to write a very efficient version. I don't know how. Right? Then I prompted, we'll discuss str in a second, and I'll explain why it's kind of weird. The other prompt is your programmer using an assistant, give it prompts to generate code for you. So I try to actually square the problem by saying, you know what, I hate generating like good prompts and everything, which is difficult. So let me use that guy to generate its own prompts. And the third prompt is you are a manager who is hiring C++ programmers to write code and figure out which is good and which is not. So we're going to discuss these three. So on to str. It turns out that str, I gave this problem on Twitter. Those of you who follow me incomputable on Twitter, maybe I've seen this, which is a kind of a funny problem because, again, there's no known solution. Now, here's what I said. Implement it so that you use, number one, use brute force. Oh, okay, this doesn't work. Use brute force, be ported efficient, do no unnecessary work. And it turns out that there's no other implementation than this. And it uses an infinite loop. And it uses, like, it's all non-structured programming. And you will, if you sit down and look at this carefully, you're going to see that there's no other way to implement it, which is completely weird. So you have, okay, so you have an infinite loop at the top, and then you have a structured loop at the end. Let's do this. And then you have a structured loop in the middle, but you have an early return inside the loop. Return haystack there, right, on that line. And then you have a break, a conditional break, and you have like the, the return null pointer at the very end. It turns out that if you change anything in that implementation, you're gonna run a number of risks. Number one, you're gonna test things twice. Number two, there's this danger of, imagine this, you're looking for a string that is very long in another string that's also very long, but a bit shorter. So 1 million characters, 900,000 characters, right? And it turns out that with the with the bad algorithm, just, all right, example. Oh, I gotta stay here for the camera guy. So if in the last line here, if not star h break, if you put not star haystack, the code still works. It's gonna pass all unit tests. But if you search for a string that's 1 million A's in a string that's 1 million A's followed by a B, you're gonna do 1 million times 1 million, 10 to the power of 12. That's 1 trillion steps. If you replace haystack with H, you're gonna make 1 million steps, which is like 6 orders of magnitude less work. So you avoid a very pernicious corner case by testing what's the right thing. That's why I'm saying the straight and narrow is very straight and very narrow for this particular algorithm. It turns out, I was shocked when I found out about it, because I gave this question like for hundreds of interviews at Meta and whatever companies. I gave this interview questions like as a warm-up for centuries. And 10 people implemented 11 ways. And I got like, in my whole career, I got like 2 correct answers. Like that, right? And it's very difficult. And it took me a while, it took me years to realize that if you make these small replacements, you get a function that is still correct technically, but is going to be much less efficient, right? So, okay, and my goal was the following. I know the correct implementation. I know the best implementation there is. And I'm going to convince ChatGPT to take me from whatever it generates initially, because it does generate a working solution, to say, how about you do this and that and the other, and you get me to the right version. ChatGPT did not have any of it. Did not have any of it. It got to The Shining, the movie, right? Jack Nicholson, great movie. So it can produce working code. So in that way, it did pass the interview. However, it's unable to analyze its own code critically. It gives you only textbook answers for the simple, like big O cases. It can't execute a loop mentally to figure out where it's at and what's happening there. Can't use logic and flow to reduce work. All of the questions that I gave that were very reasonable to a human programmer, how about this? What happens if that happens? What happens if that doesn't happen, etc. And then it becomes, when you press, because I was talking to an attendee earlier, when you press, it starts generating incorrect code, including ampere parentheses and crazy things, ampere braces and that kind of stuff. It becomes incompetent and compliant. You press and press and press, and it starts to make, you tell it to make an optimization. It doesn't do it. It makes it worse. And it says, oh, here's your optimized code. No, thank you very much. It's worse. But it doesn't understand its work. It agrees with everything I say, perhaps because of all that sensitivity training that it's a kind of high level at the end of the toolchain they have in ChatGPT. They say, you don't want it to be racist and to be like bad, to be nasty to you, to curse at you, you're an idiot, whatever. It doesn't do any of that. But it agrees with it. The bad outcome is that it agrees with everything you say. Oh yeah, sure, you're right, this is wrong. Let me generate the right one for you. It's still wrong, right? And sometimes it agrees, and then it generates the same exact code. It's crazy. So it doesn't have analysis and differential analysis. It doesn't understand how different solutions are different and that kind of stuff. So it can't carry a detailed discussion, and that when you increase the size of the context, sometimes you get into bad places. For example, he started arguing with me. And I said, what if you have, how is your algorithm better than mine? I asked, like, I gave it the reference, and it said, oh, my algorithm is better. How is it better? Oh, let me give you an example. And it literally started printing a string that is 1 million characters long. I mean, literally. I had to stop the thing from, like, yes, there are cases when the first implementation, mine, performs better than the second implementation, yours, right? One such case is when the first character of needle does not appear in haystack until much later. In this case, my implementation will terminate the inner loop early, while yours will always complete the inner loop. The reality was exactly the opposite. Literally exactly the opposite. Their implementation was doing all the loop, and mine, as we discussed about that comparison, it finished early. And then he tried to make, here's an example, he tried to give me an example where haystack has 1 million characters. So yeah, not a good outcome. But wait, there's more. ChatGPT is very good at generating known template tricks, and for this, I can't recommend it enough. In fact, if you take a lot of talks on YouTube about smart template tricks that you can do with C++, and you ask ChatGPT the same question, it's going to give you reasonable answers. Why? Because it trained on that stuff. It knows that stuff, right? It has seen that stuff. So the tricks that you find it either difficult to remember or to type or to even understand or whatever, it's just like you just ask ChatGPT to generate them for you and you're done. And it takes you literally like seconds, what would take you otherwise maybe half an hour, maybe half a day, maybe a day, right? So I can't recommend it enough. Things like, I need a compile time Boolean for streamability using all-stream operator, shift operator. And actually, there is a solution to this, which is kind of difficult to type. I couldn't type it out right now, right? I couldn't. And many of us couldn't, right? But it's just going to output it for you. It's like, I don't know, it's 12 lines. It's going to do it for you. You get a compile time Boolean that tells you whether something can be streamed or not. It does not generate interesting high-performance code in NVIDIA CUDA, simply because most of what's online is tutorial stuff, and most of what matters is kind of obscure in libraries that are very specialized, right? And in training, it used a bunch of these training materials, which are tutorial level. So it generates you like tropes and simple code and that kind of stuff. It's very good at explaining things and other soft skills. It's actually eerie how good it is. It's very interesting. Language features, they use examples and refactors, pretty printing, a lot of stuff. And there's products that do that. Please Google CY. It's a plain words, CY. And it's actually input error messages from your C or C++ compiler, and it gives you explanations for those. It's a great tool invented by Emery Berger, who's a professor at the University of Amherst and a friend, and also my coworker Bryce Lelbach, who actually is one of the C++ experts. And they wrote this tool, which is very good at a very complicated template message, and you input it into ChatGPT, and it's going to give you, oh, you didn't define your hash operator, right? Like easy, simple, and sometimes it can generate the code for you. It's amazing. Debugging ChatDBG is very good at helping with debugging stuff, but it's a mediocre interviewer in a sense that it can't overcome its own limitations, which is in a way expected, but I had to test that, right? We have to test that to make sure that we're drawing the right conclusions here. It generates poor prompts for interviewees, and it reaches a fixed point whereby it can't overcome its own mediocrity, right? Let me give an example. I gave it in 3 different instances, 3 different screens, 3 candidates, A, B, and C. And it asked a number of classic C++ interview questions, not too difficult, difference between class and struct, things that we all know pretty well. Implement a singleton design pattern, which is about the worst design pattern there is, right? But that's just an aside. And I made that comment because, I mean, come on, right? Explain polymorphism and that kind of stuff. How do you handle memory leaks? So, and then ChatGPT asked the question, another instance of ChatGPT answered the question, and yet another instance of ChatGPT answered the questions, and I answered the questions. And I couldn't stop myself. I said, actually, singleton is kind of a dumb pattern to ask me to write. But I'll write it anyway. So I wrote it down, and I submitted my interview to the interviewer. Candidate A, so okay, then it gave the verdict. Who is going to get hired? Candidate A stands out for the detail and clear explanations, whatever explaining skills, great. Candidate A was ChatGPT 3.5. Was the worst ChatGPT. Candidate B, who did not get hired, was ChatGPT 4. And candidate C was me. I was candidate C, the worst of the pack. I got 85 in technical knowledge, 75 in problem-solving skills. I mean, and 85 in communication skills. But the other ChatGPTs got a lot better, right? So hire, this is kind of interesting because it illustrates one problem that is known in management since a long time, which is the following. There's this saying: A people hire A plus people. B people hire C and D people. Which means if you get the interviewers to be not so good programmers, they're going to hire people who are not as good as them. And that's going to create this descending spiral, because then the new interviewers are going to be from the people who got hired, which are not the best ones. So there's going to be this decreasing spiral, which we do see in IT companies, sadly, quite often. I'm not going to name names, but there are a few companies that you can see. Yeah, I know. I'm not going to name names. Like Yahoo. I'm not going to name names except for Yahoo. So Yahoo, there's been this trend. They had a very good, I know because I had friends there. It's not I broke up friendship, they moved. Just making sure. So there's companies for which, they have the state and it's not going well, and then they hire worse people, and the worse people are going to hire worse people, and it's very difficult to come back from that, right? And the same happens with ChatGPT. It's a very illustration of the proverb, right? Which is kind of sad. Now, ChatGPT 4 is actually a helper with its own quirks, but it's not a good peer for you. Prompt sensitivity, context fatigue, cognitive dissonance, lack of originality, it has all of these. We discussed most of these. We discussed the cognitive dissonance. It always agrees with it because of the sensitivity training, but then it just said it agreed, but it didn't actually understand what it agreed with, right? That kind of stuff. So that's kind of bad, right? That's kind of sad. I'm going to say a few words in closing about creativity, taste, and skill. It is my opinion that to write good code, you need all three. You need to have the fluency, you need to understand what the language you're working in, you need creativity, you need taste. And there's one aspect in which AI helps, and that's the skill. It does not help with taste, and it does not help with creativity, at least not today. It helps with skill. The best used examples of ChatGPT that I've seen were this: I'm a C++ programmer, and I got this great JavaScript application to work. Transfer of skill from one to, you had the taste, you had the creativity, you had what it takes to be a good programmer, but in a different language. You had no idea about JavaScript. And it did it for you because you knew what to ask for and knew how to evaluate the solution. And this is the great equalizer. It does not equalize creativity. That's becoming your superpower. What you have right now, which is most valuable in the future, is your creativity and your taste. Because if you're missing these, AI is going to eat your lunch because it can't do the skill for you, right? So, for skill, ChatGPT rates great. It knows LaTeX, it knows PyChart, knows Python, knows PyTorch. It generates amazing graphics and a variety of great things. And the fact that it knows LaTeX is amazing because I don't know LaTeX and I'm using it. So I'm very happy. Taste a bit, just like, taste, kind of, not quite. Creativity, not there. Creativity is not there. You need to bring your own creativity to the table. That's where you're going to shine. So your creativity and taste are going to become, or already are, 10x more portable than anything else. Across languages and APIs and whatever, it's very easy now with ChatGPT to learn a new API and use it. Just in minutes, you're good, right? You just need the talent, you just need your creativity and taste. So that's going to increase the mobility of experts. You can move from C++ to other languages. You can move from the APIs you currently use to other APIs and so on and so forth. with ease with the help of these LLMs. And, you know, there are things that ChatGPT can't do. And we discussed this a bit, like, you know, classic binary search it generated, but more, you know, more clever binary search version, it just didn't do well, right? But would you, I mean, let me ask you this. Would you make fun of your teenager son or nephew who's trying to help? Or would you kind of be nice to them and, you know, use them when you can and teach them what you can and whatever, so be kind to them? The same attitude, I mean, I'm seeing too many articles that make fun of ChatGPT as if it's stupid. Actually, wait a second, it's a teenager. It just, you know, it just came up. It's growing, it's still little. It needs to learn. So use it as an assistant, don't make fun of it as a replacement, right? So what it can do, you know, as I said, it's all of the creativity and taste. So let me get to prediction, the whole prediction thing. Prediction number 0, LLMs can replace introspection. It can generate code for you that is an interface to other pieces of code. It's like I have this class coming from Python or from, you know, foreign language or from foreign API. I need to adapt this API to it. Do it for me. And that's like hundreds or thousands of lines that are like forwarding functions and all that nonsense that you need to write otherwise, and it can do it for you. This tool, I think, is going to come very soon. Not there yet. I'm working on this. Actually, I'm working on exactly this kind of stuff. I want in my make file to say, generate a wrapper for this class, make it a pimple. Boom. And I'm done. That would be awesome. Prediction number 1, planning. ChatGPT does not plan. It does not plan. You need to plan for it. You can ask questions in increments. It can't plan. Essentially, give it a question, it gives you the answer with 0 knowledge. It just gives you the first answer. How would you behave if all answers you could give are the first thing that comes to mind? And yeah, oh, this is an idiot, you know, that's stupid, you know, that kind of stuff. You can't. You got to do the planning part. So you can actually do planning for it. And in the future, I predict that planning is going to come. Prediction number 2, there's going to be multiple agents because it's a cheap way to multiply the state of these models. You're going to have multiple programmers in a team, multiple roles, multiple things, many of them filled with AI, which you're going to coordinate. That's a very easy way and very effective way to multiply context because context is limited for each of these agents. Prediction number 3, it's already here. Short-term versus long-term versus institutional memory. There's already models on the market like Claude that actually incorporate this kind of stuff. So we want to have like the long-term training, which is all code written ever. And then there's the institutional memory, which is all code in your code base. And there's a short-term memory, which is like this file. Right now, there's no such distinction, but there are tools already that do that kind of stuff. And those are coming. I mean, they're already here, but they're not very popular yet. They're coming in force. And prediction number 4, AI tools for code integrate with today's tools as a power multiplier. And ChatGPT is DBG is the first salvo. This has been done. It's called, come on, GitHub Copilot. Thank you. GitHub Copilot is there. It's in Visual Studio Code. You just press Control Enter. Did you know? You may have it and not know about it. Maybe your company installed it for you. You press Control Enter on a piece of code. It generates suggestions for you what to write next. And they're good. And they're integrated. You just choose number 1. Sure. So that's already there. So there's impact on methodology. You know, code, documentation, unit tests. They all assume we do them. But now what you do with a different actor is going to do them for you. That's going to be awesome. In an AI environment, best format for generating the others is going to be the first thing you work on. I'm seeing somebody who's taking pictures as if, oh, wow, this is really interesting. I'm going to put it on Twitter and make this guy look like an idiot. Summary. Don't short sell large language models. Learn them, use them, and be kind with them because they're coming. And all of this is going to be recorded, so they're going to know I'm friendly, right? So right now, there's a limited but considerable applicability to system code. Your creativity and your taste are your superpowers. These are, you're gonna carry them with you into the next decade, friends. This is probably the top thing that you should remember. Your creativity and taste, those you should sharpen. The skill, API knowledge, maybe not as much, right? Oddities, peculiarities, whatever, make no mistake, this is unprecedented and huge. Don't think ChatGPT is a joke. Use it, learn it, be happy with it. Right now, AI is the worst it's gonna ever be. Thank you very much. Thank you.